Right now, beneath the scorching deserts of Ethiopia, something extraordinary is happening. The ground is literally tearing apart. Magma is rising from deep within the earth, and an entirely new ocean is beginning to form. This isn't science fiction. This is happening right now, in real time. In 50 million years, a chunk of Africa will break away completely. And between the continents, where there is now desert, there will be a vast ocean stretching thousands of miles. Ships will sail where camels once walked. But here's what makes this even more incredible. We're witnessing the early stages of this process today. Scientists are watching it unfold, measuring it, and documenting one of the most dramatic geological events on our planet. This is the story of how Africa is splitting in half, and how Earth's newest ocean is being born. Our story begins in one of the most inhospitable places on Earth, the Afar region of Ethiopia. The Afar Triangle, also known as the Afar Depression, is a geological wonderland. This is one of the lowest places on Earth, sitting more than 100 meters below sea level in some areas. Temperatures regularly exceed 50 degrees Celsius. That's 122 degrees Fahrenheit. The landscape is dominated by salt flats, volcanic craters, and an otherworldly terrain that looks more like Mars than Earth. But what makes Afar truly unique isn't what's on the surface, it's what's happening deep below. In September 2005, something remarkable happened that would change our understanding of continental rifting forever. Over the course of just a few weeks, a 60-kilometer crack opened in the desert. That's 37 miles, roughly the distance from San Francisco to Oakland, or from central London to Gatwick Airport. This wasn't a slow, gradual process. This was geological violence happening at breakneck speed. The ground shook with thousands of earthquakes. Volcanic eruptions sent ash and gas into the atmosphere. And when the dust settled, scientists found something unprecedented. A massive fissure, in places up to 8 meters wide, had simply opened up in the Earth's crust. Dr. Cindy Ebinger, a geophysicist who studied this event, described it as watching ocean floor formation, but on land. For the first time in human history, scientists could observe, measure, and study the birth of a new ocean basin in real time. But to understand what's really happening in Afar, we need to zoom out and look at the bigger picture, because this is about much more than one crack in the desert. Earth's surface isn't solid. It's broken into massive pieces called tectonic plates that float on the semi-molten rock of the mantle below. These plates are constantly moving, usually just a few centimeters per year, about the same rate your fingernails grow. Most of the time, we only notice plate tectonics when something dramatic happens. An earthquake, a volcanic eruption, a tsunami. But the slow, steady movement of these plates is constantly reshaping our planet. Now, there are places where plates collide, creating mountain ranges like the Himalayas. There are places where one plate slides beneath another, creating deep ocean trenches and volcanic arcs. And then there are places where plates move apart. And this is what's happening in East Africa. The East African Rift System is one of the most dramatic examples of continental rifting on Earth today. It stretches over 3,000 kilometers, from the Afar region in Ethiopia, through Kenya, Tanzania, and all the way down to Mozambique. This rift system is actually made up of two main branches: the Eastern Rift, which runs through Ethiopia and Kenya, and the Western Rift, which runs through Uganda, Rwanda, Burundi, and Tanzania. Together, they form a giant Y shape that's slowly tearing the African continent apart. But what's causing this split? The answer lies deep beneath the surface, in a massive upwelling of hot rock from the mantle called the Afar Plume, or the East African Plume. Imagine a colossal column of superheated rock, hundreds of kilometers across, rising from deep within the Earth's mantle. This plume carries immense heat and pressure upward. When it reaches the base of the continental crust, it pushes upward, creating a dome-like bulge at the surface. This is what's called a mantle plume, a thermal anomaly that can persist for millions of years. The Hawaiian Islands were formed by a mantle plume. So was Iceland. And now, one is actively splitting Africa. As this massive plume of hot rock rises, it does two things. First, it physically pushes the crust upward, creating the elevated plateaus we see in East Africa. Second, and more importantly, it weakens the crust, making it easier for the tectonic plates to pull apart. In the Afar region specifically, three tectonic plates are meeting and moving apart. The Nubian plate, which comprises most of Africa, the Somali plate, which includes the Horn of Africa, and the Arabian plate. The Arabian plate is pulling away to the northeast at about 2.5 centimeters per year. The Somali plate is pulling away to the southeast at about 5 to 10 millimeters per year. And caught in the middle is the Afar region, being stretched, thinned, and torn apart. Over millions of years, this stretching has created a massive depression. The Afar triangle sits at the junction of three divergent boundaries, making it a triple junction, one of the most geologically active spots on the planet. So, how do we know all this? How can scientists be so certain about what's happening miles beneath the surface? The answer is data, lots of it, collected through multiple cutting-edge technologies. First, there's satellite imagery. Using GPS and satellite-based radar interferometry, scientists can measure ground deformation with incredible precision. They can detect changes in the Earth's surface, down to millimeters, tracking exactly how much the ground is moving, stretching, or sinking. Data from satellites like ESA's Sentinel-1 and NASA's GRACE mission have shown that the Afar region is subsiding, sinking, as the rift valley deepens. Meanwhile, the edges of the rift are being uplifted as magma pushes up from below. Second, there's seismic data. Networks of seismometers throughout East Africa continuously monitor earthquake activity. And there's a lot to monitor. The region experiences thousands of small earthquakes every year. By analyzing the seismic waves from these earthquakes, scientists can create detailed images of what's beneath the surface. It's like giving the Earth a CT scan. These seismic tomography studies have revealed the structure of the mantle plume itself, showing a massive column of anomalously hot rock extending from the deep mantle all the way to the crust. One fascinating discovery from seismic data is that the crust beneath the Afar region is extraordinarily thin. In some places, just 15 to 20 kilometers thick. For comparison, normal continental crust is typically 30 to 50 kilometers thick. This thinning is direct evidence that the continent is being stretched and torn apart. Third, there's geochemical analysis. When volcanic eruptions occur in the rift, they bring up material from deep within the Earth. By analyzing the chemical composition of volcanic rocks and gases, scientists can determine where the magma came from, how hot it is, and what's driving its ascent. Studies of basalt flows in Afar have shown they have a chemical signature consistent with deep mantle origins, confirming that the magma is being supplied by the mantle plume rising from below. Fourth, there's GPS tracking. Permanent GPS stations throughout East Africa continuously measure how fast and in what direction the ground is moving. This data has confirmed that the Arabian plate is pulling away from Africa at about 2.5 centimeters per year, while the Somali plate is separating from the Nubian plate at about 5 to 10 millimeters per year. These might sound like tiny movements, but over geological time, they add up. In just 1 million years, at current rates, the Somali plate will have moved 5 to 10 kilometers farther away. In 10 million years, 50 to 100 kilometers. In 50 million years, we're talking about several hundred kilometers, enough for a full ocean basin to form. But perhaps the most dramatic evidence comes from recent volcanic activity. And this brings us to one of the most significant recent events in the region. In November 2023, something remarkable happened. A volcano that hadn't erupted in recent memory suddenly roared to life. Hali Gubbi, a volcanic system in the Afar region, began erupting. Fissures opened in the ground, releasing streams of molten lava. Fresh basalt flows spread across the landscape. Volcanic gases billowed into the atmosphere, and local communities watched as the earth literally opened up before their eyes. This wasn't just another volcanic eruption. It was a direct demonstration of the rifting process in action. The Hali Gubbi eruption produced what geologists call fissure eruptions. Unlike the cone-shaped volcanoes many of us picture, like Mount Fuji or Mount St. Helens, fissure eruptions occur when magma rises through long linear cracks in the crust. The lava flows out along the length of the fissure, creating broad, flat sheets of basalt. This is exactly what happens at mid-ocean ridges, the underwater mountain ranges where oceanic crust is being created as tectonic plates pull apart. In fact, the type of basalt produced at Hali Gubbi is chemically similar to mid-ocean ridge basalts. In other words, what's happening in Afar is essentially the same process that creates new ocean floor at the bottom of the Atlantic or Pacific Oceans. The only difference is that it's happening on land, where we can see it, study it, and document it. The fresh basalt flows from Hali Gubbi are still visible today. Dark, glassy rock that cooled from molten lava just months ago. Walking across these flows would be like walking across brand new Earth crust, material that quite literally did not exist a year ago. But here's what makes this even more significant. This eruption, and others like it, are adding new material to the Rift Valley. They're literally building the foundation of what will eventually become ocean floor. Scientists studying the Hali Gubbi eruption collected samples of the lava, measured gas emissions, and used satellite data to track the deformation of the ground. What they found confirmed what models had predicted. The eruption was fed by magma rising from a shallow magma chamber, which in turn was being supplied by deeper magma sources connected to the Mantle plume. This is the rifting process in action. A cycle of stretching, magma intrusion, volcanic eruption, and the creation of new crust. It's a process that has repeated countless times over millions of years and will continue for millions more. So what happens next? Where is this all heading? Based on current rates of movement and geological models, scientists can make some fascinating predictions about Africa's future. In the relatively near future, geologically speaking, the Arabian Peninsula will continue moving away from Africa. The Red Sea, which is already a young ocean basin, will continue to widen. In 10 to 20 million years, it will look much like the Atlantic Ocean does today. Meanwhile, in East Africa, the rifting will continue. The Afar region will continue to sink and widen. More volcanic eruptions will occur. More fissures will open. And gradually, the continental crust will thin to the point where it transitions to oceanic crust. In approximately 50 million years, give or take a few million, the process will be complete. The Somali plate carrying the Horn of Africa and much of East Africa, will have fully separated from the rest of the continent. Between them will be a new ocean. Let's call it the East African Ocean, though it doesn't have an official name yet. This ocean will be connected to the Red Sea and the Gulf of Aden, forming a continuous body of water that extends from the Mediterranean through the Red Sea and down through what is now the East African Rift. This new ocean will be home to mid-ocean ridges, where new oceanic crust continues to be created. It will have its own unique ecosystems, ocean currents, and marine life. Islands may form from volcanic activity, similar to Iceland or the Galapagos. The coastline of mainland Africa will be dramatically different. Cities that are now inland, like Nairobi or Addis Ababa, might become coastal cities, or even find themselves on different continents entirely. And here's the really mind-blowing part. This isn't the first time something like this has happened. Earth's continents have been breaking apart and coming back together in cycles for billions of years. Around 200 million years ago, all of Earth's continents were joined in a supercontinent called Pangaea. Then it began to break apart, a process similar to what's happening in Africa today. The Atlantic Ocean formed as the Americas drifted away from Europe and Africa. The Indian Ocean formed as India broke away and drifted north toward Asia. What we're witnessing in East Africa is the same fundamental process that has shaped our planet throughout its history. We just happen to be living at a time when we can observe it, study it, and understand it. And that's what makes the Afar region so extraordinary. It's a natural laboratory for studying how continents break apart and oceans form. The processes that are usually hidden beneath kilometers of ocean water are happening here on land, where scientists can access them, measure them, and learn from them. The splitting of Africa is a reminder of just how dynamic our planet is. The ground beneath our feet might feel solid and permanent, but over the vast stretches of geological time, continents drift, mountains rise and erode, and oceans open and close. In the Afar region of Ethiopia, we're watching this process unfold in real time. Deep beneath the desert, magma is rising. The crust is thinning and breaking, and slowly but surely, a new ocean is beginning to form. 50 million years from now, Earth will look different. Africa will be split. A new ocean will separate the continents. And all of it will trace back to the processes we're observing today. The Earth is constantly remaking itself. And in places like Afar, we have a front-row seat to watch it happen. What do you think about this incredible geological process? Have you learned something new about our dynamic planet? Let us know in the comments below. We love hearing your thoughts and questions. And if you enjoyed this deep dive into Earth science, don't forget to subscribe and hit the notification bell so you never miss our next video. We're exploring the most fascinating phenomena on our planet, from the depths of the ocean to the heights of the atmosphere. Thanks for watching, and we'll see you in the next one.